Hello and welcome to my video 7.1 about enlargements and scale diagrams. So first of all, I'm going to start with a question. What is scale factor? Because this is a word we're going to be using all throughout the first little bit of this unit. So what is scale factor? Well, let's see here. We have two different rectangles, and the question is, what is the scale factor between them? So first we have to recognize that one of them is the original, one of them is the diagram. And it doesn't actually tell you here, so what I'm going to do is I'm going to draw a little arrow to say that this is the direction that we're looking right now, in red. Okay? So with that in mind, let's count all the squares on the left. So there are going to be 4 squares here. If we count all the ones on top, you can go ahead and count them. There'll be 6. And it goes to a 2 by 3 rectangle over here. So what is the scale factor? Well, if you look at those numbers, we can see that it actually divides by 2. Right? So if it's dividing by 2, so divide by 2. So if it's dividing by 2, it actually shrinks by a half, or what we say is that the scale factor is 1/2, okay, or 0.5, whichever one you prefer. Okay, so the scale factor is what you multiply by to get the other side. So you multiply the first one by 1/2 to get the other one. Okay, what about if we had it the other way? Well, instead of being a half, it would be 2. So you're multiplying by 2 now. And so now we get 3 times by 2 is 6, 2 times by 2 is 4. So that would be the other direction. So let's draw an arrow like this and times by 2. All right. Hopefully that makes a little bit of sense. The other common sort of understanding or guess would be to say, well, the scale factor is 4, but that's not actually true. So we're not looking at the area, which is what I'm going to shade right now. You're right that there are 4 amounts of the smaller rectangle in the big rectangle, but we're looking at length, not area. So area is always length squared. So if we go times by 2, it's going to be 4. Okay, so it's always squared of whatever you have. So it's not looking at area, we're looking at length. Okay. Let's look down at this next one. At this point, now that we've seen these ones, we should be able to try this one and probably figure it out. So, what is, whoops, if this circle has a radius of 2, okay, so if you look here, it has a radius r equals 2. How big is the radius of the enlargement after being enlarged by a factor of 3? Well, here is the really big circle that we're going to have. So might have to zoom out actually. We need quite a bit here, because it needs to have a radius of 6. So let's zoom out even more. So let's try to redraw that now. There you go. And now we have that enlarged by a factor of 3. And so you can see that it makes a huge difference when we enlarge the radius, or when we change the length of anything by a factor. It's going to make a big difference, whereas if we change the area, it would make a much smaller difference. So this looks like a lot more than 3 times the size, but if we're looking at length, it is 3 times the size. So that's the question. Are you looking at area or length? And always we're going to be looking at length. Okay. Oops, I wrote this circle. I meant to write this square is enlarged by a scale factor of 2. Draw the diagram. Okay. We can do this one by figuring out that this is 3, This is 3, so we should have 6 by 6. So let's try that right now. So it's 4, 5, 6. 4, 5, 6. There you go. So that's our final product. So hopefully you can see from the following different shapes and enlargements that scale, factor, and scale diagrams are not that difficult. And if you try out a couple, then you'll have it ingrained in your mind and you'll do well. So good luck.